Hi everyone, in this research project I want to talk about projection of the retirement wealth, which is a case study. In this case study, I worked on a data set belonging to a superannuation company and tried to estimate their customers' account balance in retirement age. The objective of this case study is to estimate whether a person will have enough saving in retirement age or not. And then I compared our result with ASFA retirement standard. Why projection of the retirement wealth matter? According to ASFA, the Association of Superannuation Funds of Australia, right now, 1 in 4 men and 1 in 3 women have no superannuation saving when they retire, and more than 50% of the retired people are using age pension because they are under ASFA retirement standard. So at the moment, there is a retirement crisis in Australia. If we truly want to have enough balance in retirement age, we need to have a solid plan. This research gives us a big picture about our financial situation in retired age. Actually, by having an idea about the retirement balance, we can prevent the risk of decreased retirement preparedness. We can develop your economic thinking and improve our strategies for retirement wealth management. How the projection of the retirement wealth can help? Some people can't estimate how much saving they should have in their account for a comfortable retirement. By this projection calculator, they can find out whether they will face with a financial shortfall in age 67 or not, and then they can plan to boost their saving before retirement age. Our key contribution in this research is a different methodology we have for calculating account balance in retired age. We use a stratified sampling method and a median function in the estimating process, which is a different approach to retirement calculator challenges. There are two famous standards, ASFA and SAFA, in related to retirement wealth. We use these two standards in our research based on the ASFA, which is Associations of Superannuation Funds of Australia. Based on this table, a comfortable retirement for a couple is 640,000 and for the single is 545,000, and for modest retirement is 70,000. SAFA, which is Socio-Economic Indexes for Areas, is a product defined by the Australian Bureau of Statistics for ranking areas based on the socio-economic advantages and disadvantages. There are 4 indexes in SAFA: the indexes of the relative socio-economic disadvantage, the index of the relative socio-economic advantage and disadvantage, the index of education and occupation, the index of economic resources. We use the index of relative socio-economic advantage and disadvantage in our project because this index indicates advantage area as a high income and a high degree qualification, and disadvantage area as an employment status and low income. We find out SAFA indexes in each postcode and use it in our project method. At the first stage, we explore the dataset. The dataset is from CFS Colonial First Estate, which is a superannuation company. Here, figure 1 shows the majority of the population are in the age between 40 and 60 years old. And figure 7 shows there is a balance between the number of the females and males. And figure 6 shows how SAFA index distributed in our dataset, which means those people live in high score socioeconomic area have superannuation account more than low score area. Here we explore more about data features. This graph shows distribution of account balance based on the SAFA. We can see those people living in high score socioeconomic area, SAFA 8, 9, 10, they have a more saving in compared with those people living in the low score socioeconomic area, SAFA 1, 2, and 3. This graph shows distribution of account and last year gross balance based on the SAFA, and we can see that there is a correlation between gross last year and account balance in this graph. This graph shows the correlation between account balance and gross last year based on the age, and also we can see those customers that are age between 50 and 60, they have a more saving in compared with the other ages. This is the scatter plot of the account balance by SAFA colored by gender. In this graph we can see the contribution of the females in lowest SAFA like 2 and 3 and 4 is very less in compared with the upper SAFA scores. It means in this data set those females living in low score socioeconomic area, lowest CFA like 2, 3, 4, they don't have a superannuation account, and maybe they don't have a booked job, and the number of the females live in CFA 2, 3, and 4 is zero, almost zero, and they don't have any superannuation account. In this slide, I will talk about our projection method. The projection calculator utilizes a stratified sampling method in population and observe for age, gender, last year balance growth, and CFA index in dataset. First, we find out those customers have the same gender, same age, and CFA. And we take 100 customers, those have close balance to our customer query. And then we calculate the median of growth last year of that 100 similar customers. And finally, we add the median results to the current balance of the customer to estimate next year saving balance. We repeat this process till we reach to projection of saving balance in age 67. For example, here we have one customer query, his age is 45, CFA is 7, and gender is male. We find out in our population those customers that are close and similar with this customer's information, and we filter 100 customers as a sampling data, and in respect of the account balance is close to this customer, and then we calculate the median of this 100 customers and add the result of the median to current account balance of the customer query, and in this way we project the next year account balance of this customer. We repeat this process until we reach to retired age, which is 67. In this slide, I will explain how we calculate the median of the gross last year and how we estimate the next year bank account balance of the customers. In this table, we already selected 100 similarity matching. That's the sample data we have. We took it from population. So we can see the CFA is same, gender is same, age is same. So the table is ready to calculate the median of the gross last year. We sort this column and we calculate the median of this column, and we add the result of the median to the current account balance of the customer, and then we add the results to this column, which is next year prediction of the next year of the account balance of this customer. So we continue this method, this process, until we reach to age 67, which is retired age. In this way, we estimate the account balance of this customer query when he is retired. Why we use the median function in our projection method? When we have outliers and sampling fluctuation in distribution, we need to use median function if we want to ignore outliers and reduce that fluctuation. In our data set, as I show you in this graph, we have some outliers that can negatively affect in our results. That's why we have to use a median to remove these negative effects. So let me explain to you with this example. Imagine we have this data series 1, 2, 3, 4, and 1000. 1000 here is outliers. If we calculate the mean of this data series is almost 200, and if we calculate the median of this data series, will be the result is 3. So it's clear, we can see the 3 is reasonable representative of this data series, because there are at least 3 value close to the 3 here. But 200 cannot be reasonable representative of this data series, because we don't have any value around of the 200, and also even 1000 is cannot be matched with 200 as well. So in this way, we can see how we remove that this outlier by using and utilizing the median. So we use the median in our project and we got a good result. Here there's some result, I got it from Python. So we can see this guy in age 38, he has a $320,000, and in his retired age he will have $460,000. Here we can see this guy in age 33, he has a $90,000. When he retired, he will have $200,000. He lives in Safa 4, he lives in Safa 10. This guy lives in Safa 1. He has a $9,000 here, and in age 49, when he retired, he will have $60,000. So we can see how Safa can affect on saving balance of the customers. Those customers living in low score socioeconomic area, they have a low balance, and those customers living in the high score socioeconomic area, they have, or usually they have a more saving balance. In this slide, I just compared our result with ASWA retirement standard. As you can see, only 23% of the customers meet the comfortable single standard. What's the comfortable single standard is $545,000. So it means only 20% of the customers, when they retire, they have this much money in their accounts. And only 78% of the customers, when they retire, they have a $70,000 in their account, which is modest standard. And this table shows 3% of the customers, those that live in the Safa 1, they meet the comfortable standards, and 73% of the people that live in Safa 1 meet the modest standard. So even in Safa 10, only 42% of the customers meet the comfortable standards. Is still lower than 50%, so low. This result shows there is retirement crisis in Australia. We got a good result, however, our method has a few limitations. First, we could consider more characteristics in the sampling frame to improve the accuracy of our projection method. We can add more parameters like material status and occupation. Second, we only worked on a small data set with about 200,000 CFS customers. So we can perhaps improve this projection method by further expanding data and including other parameters in the sample selection phase. Third, this method considers only the current financial situation of customers. Maybe some other unpredictable events will happen to cause a big change in the superannuation balance, and we didn't consider it here. This case study is performed in November 2020. We are still working on the new approaches like machine learning or using standard deviation and mode function to increase and improve our projection method. I hope this projection of retirement wealth tools we created by Python will be helpful for customers and can develop our economic thinking and improve our strategies for retirement wealth management.